We're going to look at another type of dirt problem, or a distance rate time problem. This one where we have something working either with or against us. So these are called distance rate time or dirt problems with current. This would be with boats or swimming or something where you're in a body of water where there is a current, some action that is working either against you or with you. So in a river where there's a current, you'd have upstream, which is where the current is going to slow you down. So you're going to have your rate of your boat, or the rate you are swimming at, working against the current, and so it'll be minus the c. Then there's going downstream where the current is pushing you, so you're going to have your rate plus the current, and it's going to be making you go faster. The R stands for the rate in still water of whatever it is. If you were swimming, it would be the rate you would swim in say a swimming pool instead of in a river. Or if it was a boat, it would be like rowing or motoring on a lake instead of a river where there's no current at all. Besides boats and within water, we could have in the air an airplane. And so we could have these same types of problems where it's an airplane and the wind. And so you either have you are flying against the wind, so you'd have the rate, the speed you are trying to fly, and then the wind is slowing you down because you're flying against the wind, or you could be flying with the wind, in which therefore the wind would speed the plane up. Now this R minus W, or the R plus W, would be the speed that it would look like from the ground. As someone was standing on the ground looking up at the plane, they'd say, look how fast that plane is flying. That would be the ground speed that you would see. So let's start off doing one of these dirt problems. We need to have a chart. Just like we've had other distance rate time problems, we have the same chart. But in the other types of distance rate and time problems, you'd have your object 1 and your object 2, train X and the train Y, or, the car going, versus the truck or something like that. But with these problems, it's the same object, the same boat, or the same plane that's flying. And instead of object 1 and object 2, what you're going to have is like downstream and upstream, or you're going to have with the wind or against the wind. And that's how the difference in the way the chart will get filled out. So let's look at our first problem. And in this problem, we have Manuel, who has a boat that can move at a speed of 15 kilometers per hour in still water. So we have his actual speed of the boat, the R. And he's going to ride his boat 140 kilometers downstream in the same amount of time it takes to ride 35 kilometers upstream. What our question is going to be, what is the speed of the river? The current is what we want to solve for in this problem. So first of all, we have this information about the boat speed, meaning the rate is 15 kilometers per hour. And we also have the distance of downstream and upstream. So we're going to fill that out, and of course C is unknown. Filling out the chart, we've got our downstream and upstream distances of 140 kilometers and 35 kilometers. Our rates, where we've got the 15 plus the current and the 15 minus the current, corresponding with upstream and downstream. The time is the same in both situations. Therefore, we kind of discount the time because we're going to therefore look at the ratio of distance to rate. So let's write that as the ratio of 140 as to 15 plus c, which is equal to 35 as to 15 minus c. So we have a proportion. And we're going to cross multiply to solve for this. And when we cross multiply, we get 140 times the quantity 15 minus c equals 35 times the quantity 15 plus c. We will use the distributive property and get 2,100 minus 140c equals 525 plus 35c. We'll add 140c to both sides, and as well as we will subtract 525 from both sides to get all of our c's. In this case, we'll get all of our c's over on the right and all of our numbers on the left. And so we get 1,575 equals 175c. Divide by 175, and we get that c equals 9. And we have to remind ourselves, well, what is c? Well, c is the current of the river, meaning the speed of the river, which is what we were there to solve for. So we do know that the speed of the river is 9 kilometers per hour.